Hey everyone, it's Andrew here, and today we're back with another USACO problem. So, today we're going to be tackling the problem 3 of the 2020 December contest in the bronze division called Stuck in a Rut. Now, the problem 3 of USACO contest is usually the most difficult one, and in this case, that's applied here. This one is probably by far the most time consuming problem of all the problems in this contest. So, without any further ado, let's just jump into it. Alright, so let's just start reading here. So, Farmer John has recently expanded the size of his farm. So, from the perspective of the cows, it is effectively now infinite in size. So, the cows think of the grazing area of the farm as an infinite 2D grid of square cells, each filled with delicious grass. Think of each cell as a square in an infinite chessboard. Each of Farmer John's end cows, and is between 1 and 50, starts out in a different cell. Some start facing north, and some start facing east. So it seems that we have a chessboard, and let's just say that each cow fills up one square, and they all start at different squares, and some of them face north, some of them face east. Alright, so every hour, each cow either stops if all the grass in her current cell was already eaten by another cow, or eats all the grass in her current cell and moves one cell forward according to the direction she faces. Over time, each cow therefore leaves a barren rut of empty cells behind her. So if two cows move onto the same grassy cell in the same move, they share the cell and continue moving in the respective direction to the next hour. Please determine the amount of grass eaten by each cow. Some cows never stop and therefore eat an infinite amount of grass. Alright, so that was a lot of information to take in, but either way, basically what we know is that we have basically some sort of chess coordinate or some coordinate system, and or not coordinate system, just like a sort of chessboard. And basically, we have cows that face east and cows that face north. And let's just say that, and basically for cows that move east or move north, as they move, they leave a barren rut behind them. So basically, if let's just say this north cow has moved 14 four times in 4 hours, that means the four barren ruts behind her will all be taken. And if a cow runs into this cow will stop. And basically, same goes for these cows. For the north cows, if they run into a barren rut left by the east cow, let's just say that this cow has moved 3 squares and is in this direction. That means all these 3 squares are barren, and the cow cannot eat the grass there. So this one will also stop. And be sure to know that cows that travel north or east, they can't change their direction. Like this cow can't. If this cow is going north, it has to continue going north. It can't just suddenly turn east. All right. So let's just move on to the input format here. So the first line of input contains n, and each of the next n lines describes the starting location of a cow in terms of a character that is either n for north facing or e for east facing, and 2 non-negative integers x and y, giving the coordinates of a cell. All x coordinates are distinct from each other, and similarly for the y coordinates. Alright, so a cow is defined by basically their direction and their x and y coordinates. Okay, so to be clear as possible regarding direction and coordinates, if a cow is in cell xy and moves north, she ends up in cell x, y plus 1. As when north cows move, they have to move up. They can't change direction. Same goes for east cows, and therefore it would be x plus 1. So for east cows, all we really need to care about is x, and for north cows, all we need to care about is their y, because those are the only values that change. Alright, for the output format, it says print n lines of output. Line I in the output should describe the number of cells worth of grass in the ith cow that the input eats. If a cow eats an infinite amount of grass, output infinity for that cow. Alright, so if we just take a look at these, we can see that the cow that starts facing east at 3, 5 will eat, in this case, 5 squares of grass, and then for n, 5, 3, you will eat 3 squares of grass. E4, 6 will eat infinity, and so on. So that's just how it's organized. But anyways, let's just take a look on how we're going to basically solve this problem, how we're going to approach it, and maybe we can just try figuring out the sample input and sample output. Alright guys, so I've actually created some slides because I actually thought that this the solution to this problem is actually really smart, even though that it takes quite a while, because when I took this problem in the contest, it actually took me a really long time to solve. And so I just made some slides about it because the process surely is kind of confusing and long. So here we go. So the first thing I did was I created a 2D array of size n squared, obviously, as basically each cow is basically a coordinate plane or coordinate system. Oops. And to hold their the input coordinates and their index. Oops. And then I created 2 tree maps. So if you don't know what a tree map is, basically it's like if you know what a map is, it's like a data structure where there's a key and a value, like a dictionary. Every word has a definition. So a tree map is the same thing as a map, except that it's actually sorted in ascending order. So I created 2 tree maps for both north-facing cows and east-facing cows, sorted by their x and y values respectively. So in this case, north cows are sorted by their x value, and east cows are sorted by their y value. Well, why is that? Well, east cows, we sort them by their y value because their x value doesn't really matter. Well, because in this case, they're always going to be heading in the x direction. So what we need to pinpoint is how which one is the closest one that's going to be basically be able to collide to a north one, which is sorted by their x values. So basically we use the y value of the east cows and the x value of the north cows in order to check whether each one will collide. So east cows with the lowest y value will have the first collision with north facing cows. Well, what do I mean by that? Well, basically that means for any 2 cows that are going to collide, basically the one that is basically of all the east cows, the one that has the lowest y value, or basically the one that is closest to all of the north cows, is going to collide first. Or and also the cows don't have to collide, but in this case we're considering that they will collide, and we can also check whether they won't collide or not later on. So then we're going to create an array that will hold distances each cow traveled. So in this problem, if you remember, basically the thing that we're trying to pinpoint is the amount of distance each cow is covered before being stopped by another cow. And cows that don't stop will be labeled as infinity. So we're going to create an array to basically hold this data that we're going to print out. Alright, so and then we're going to create a method so that would take the coordinates of 2 cows, one facing north and east. So this is just to check whether cows are going to collide or not. And in this case we have 3 cases. 1, the cows don't collide. 2, the north cow collides against the east cow's trail, or the east cow's trail collides against the north cow's trail. And we have the math. We can use math to calculate which one will collide first, or stop first. Never mind. So so this should be the stop. But in terms of whether they will collide and which one will stop, check the differences in delta x and delta y. Well, what do I mean by that? Well, let me get the pointer on here. Well, if you look closely, let's just say that we're determining which one will collide first. In this case, let's just say 10-4 and 11-2, if you can see it here. Well, which one will collide first? Well, every hour the cows move 1 in their direction. So in this case, if 10 moves 1 in this direction, it's going to be at 11, and 11 is still going to be at 11. So in this case, we can determine that this east cow will go on to infinity, and this north cow will collide against its trail. Well, in this case, if we want to use mathematics to basically calculate which cow will collide first, since we don't always know the exact case, we can see that delta x, the differences in x in this case are, let's see here. Yeah, and the differences in x are, the differences in y value are greater than the differences in x value. For example, 11 minus 10 is 1, and 4 minus 2 is 2. So in this case, we know that the north cow is going to collide, and vice versa. It's the same thing for east cows colliding. If the change in delta x is greater than the change in delta y, that means the east cow will collide against the north cow's trail. Yeah, so I know this is kind of confusing, but basically what you need to know is that basically we're going to have a 2D array of size. We're going to create 2 tree maps that are going to hold the cows sorted by their respective x and y values, as well as their index. Basically, the second slot of the values of the tree map are going to be their index within this array right here. And then this is just describing how will they actually collide, like I just explained. And basically the method is given 2 points of east x1 y1 and north x2 y2. And basically if delta x is greater, that means the east cow will stop. If delta y is greater, the north cow will stop. In all other cases mean the cows will not collide. So pretty simple for this method here. And then from there we loop through each array, and basically colliding cows are removed from each map to check for points of collision. So from there we can basically in an orderly fashion deduce which cows are going to infinity and which cows are stopping. And basically the stopped cows are removed from the map, so we'll always go through in an orderly fashion to check each cow. Alright, so next one. So this is the sample input output walkthrough, so this is just guiding us to how we get this from this. Well, I've put all these the cow identification lines into this chart here, and basically if we have these I've already made the tree maps beforehand. Basically if we go back, basically the tree maps are sorted by their x and y values respectively, so x for north and east for y. And basically the value, there's the key and the value, so the value is going to be their index. Alright. In this case, the east tree map, they're sorted by their y values. So let's see what's in here. Well, the first thing, let's see which one has a y value of the least. So in this case, it would be this point. In this case, the y value is 4. And in this case, the index of this is the third one. So if we go back here, we can see that 0, 1, 2, 3. So this is the third cow if we're using array index. And next, we can see 5, 0. Well, which cow has a y value? Oh, never. Which cow has a y value of 5? Well, in this case, it's going to be this one. And this is 3, 5. The cow at 3, 5 going east. And in this case, this cow is the first one. So it has an index of 0. So basically, remember, the key is going to be the y value for east. The key is going to be the x value for north. And for both of them, the value, basically the definition, if we're going to use dictionary terms, is going to be the index in this original array. Or I'm going to sort it into a 2D array. Basically the ordering, the original ordering that they give us. Alright, so for 6, 2, which cow has a y value of 6? In this case, it's going to be this one. Now, where is it placed? In this case, it's going to be 0, 0, 1, 2. In this case, it's going to be the cow at 4, 6. And in this case, this is automatically sorted for us as we put in a tree map. And the same goes for north. Which north cow has an x value of 5? In this case, it's going to be the 5, 3. Where's 5, 3? It's going to be the first one. Or not the first one, the one at index 1. And in this case, I've labeled all the indexes here. Oops, let's put that back. And basically in this chart, we can I've used these color-coded labels to show that which cows go to infinity and which cows will stop. So if we just processed through this, both of these tree maps, we can see that 4, 3 goes to infinity, because if we look at this chart here, 4, 3 is going to be, let's see here, this one. And in this case, since there's no other thing that's going to collide with it based on our ordered tree maps, it's going to go to infinity. And if we cycle through that, we can see that 11, 4, or this cow over here, is going to stop at at this cow's trail. So 11, 4 cow stops at 11, 3. So in this case, just right here. Let me see here. 11, 1. Yeah. Okay. And in this case, if 4, 3 goes to infinity, that means we also have to remove it at the end, since we're going to basically go in orderly fashion. And in this case, 11.4 also gets removed as it stops, so we don't have to care about it anymore. All right, so for 5, next we go to this tree map over here, and we see 5.0. Well, if we basically process through this, we can see that 5.0 stops at 8.5, or not the cow at, let's see here, at this point. So this cow is going to stop at 8.5, basically right here. Well, why is that? Well, because we have this cow over here, and in this case, it's going to be removed. So basically, we're going to increment every time and see how the cows will collide with each other. And in this case, this array doesn't change at all. Finally, after we remove the cow that stopped right here, or at 8.5, we're going to finally process through this one, 6.2. And we can finally see that both of these collide to an already existing trail, and they're both removed. And this 6.2, if we go over here, in this case, that's going to be cow over here. There's nothing hindering it, so it's free to go, and it's going to go into infinity. And we can't really say the same for these ones, as they're both going to stop at 5.3 and 8.6 respectively, and are both removed from the map. So you might be asking, well, how do we know this? How are we going to basically know that this is going to happen? Well, I'll explain in my IDE. Alright guys, so I'm back in my IDE here, and basically I've just read in the input with some code here. And based on our slides, remember that we're sorting east by its y value, or east cows by their y value, and north cows by their x value. And I is just going to be their index within this array. Alright? So, and for scanner, as you know, basically this, or you may not know, but basically this year in 2020, USACO changed their input format from input files to standard input and standard output. So in this case, we're just going to use scanner here. And basically, like I said before, we're creating 2 tree maps, one for each north cows and east cows, and also an array of n and 2. And basically, this is just like reading in the x and y values and the character that defines whether it's east or north. And based on that, I've just put them into tree maps. So if you want this input code, you can just pause the video, and it'll be right there. But anyways, after reading in the input, what do you do now? So the first thing I'm going to do is just to declare some variables to hold the incrementing variables for the keys of the maps. So one is going to be east key, and the other is going to be north key. And let's declare a new array called distances. Let's just call it dist. And this is the array that we're going to return or print out. That's going to hold the distances that each cow traveled. And let's just fill this with zeros. You don't really have to. I don't think you have to do this, but I'm just going to do it just in case. It's what I did in the contest, so it's kind of a habit. But let's see here. What do we do? Alright, so let's declare sizes. Let's declare a variable for the north map size of the north map. And we're going to update this every time. So let's declare a temporary array. So if you don't know, when we remove something from a map, we actually have to monitor its size, because when we're running through a map, the size is going to change if we remove something. So you need to add variables to account for this. Alright, so now that that's done, let's just let's loop through the east map. So the first thing that we're going to be doing is comparing the east to the north. So we're going to start by looping through the east. So let's redeclare our east keys. So first key is a command that you can use for maps that's just going to get the first value, first key of the map. And this is whenever because if you just, let's say you remove something, it's always going to go back to that first key no matter what. And you're going to do the same thing for n key. And let's see, let's just and let's just say nc int nc let's just say this is going to be called North Cow. So let's just do NC for short. This is going to be north dot get and key. So this is just the map, the syntax for our maps. How do we deal with them? How do we use them? So this is just declaring some cows, and we're going to compare them to N key, E key, and this should be east. Alright, let me move my mic for a second. Alright, there we go. And now that we've done that, and we have these variables, we can just compare them by looping through the north map. So let's do that. 0. Oops. Okay, this is kind of awkward, but yeah, sorry. So the wire that connects to my mic is like over the keyboard, so it's kind of hard to type, but no worries. Oops. What is this? I already defined it. Oh, I think we did it in the wrong scope. Yeah, we did. Okay. Let's just move this and move out of it. Boom. There we go. And north size. Alright, and then now we can go down and declare our method. Oops. So, like I said before, if we go back to the slides, we need to create a method that would take the coordinates of two cows, one facing north and east, and returns whether they will collide and which one will stop. Check, and in this case, we have to check differences in delta x and delta y. So let's do that here. Alright, so there we go. And let's just call it, oh, which one is it? Okay, yeah. Let's call it, let's just say, static and, let's see here. Let's just say cow, collision. Nah, that's too long. Let's just say will stop. And oops, it's going to be int x1, like we said before, int y1, int x2, and int y2. And well, now let's just compare the delta. So first case, before we compare the delta values, we have to check whether the cows are actually on course for colliding. And that's only fulfilled if these conditions are met. So if you just take a look at basically just two random cows, what traits do they have to collide? Well, this cow's x value has to be greater than this cow's x value, and this cow's y value has to be less than this cow's y value. So that's what we're going to do here. This is what we're going to check in here. So if this is true, that means we have two cases, that either the east cow stops or the north cow stops. Well, like we discussed before, let's just declare the delta values. Let me move this for a sec. Alright. Oh, that's wrong here. Let's move this here. Okay. What's wrong here? Oh, I'm stupid. Now we add there, and then say return 1. So since we can't really declare anything to return Boolean values, since there's like 3 possibilities, let's just use the code in this case. So 1 is just going to be in this case, if y is greater, that means that this means that the east cow will collide first. I mean, the north cow will collide first. And in this case, the other one is just going to be if delta y is less than the delta x. That means sorry, my typing's kind of bad right now. My mouse is in a weird position. And that means return 2. So 2 is, let's just put some comments down here. So 2 is just going to mean the north stops, and this is just going to, or this is north stops, and this is east stops. Alright, so let's see here. What else do we have to do? Oh yeah, so if none of these happen, that means the cows will not collide at all. That means from there we would just return 0. And that's our method. So after our method, we need to continue with our iteration of the loop. So let's see here. We go back up here, and we go here. Alright, let's see here. Okay. And so let's just say result is just going to equal to, we're going to use our method here. Let's just declare a variable here called result. And this is going to basically remark whether the two cows will collide or not in our code. Cows, EC. Yeah, this is just a rigorous process here. Cows, EC1, cows, NC0, and cows, NC1. So what are we doing here? Well, this is just going to check every basically every combination that not every combination, but every ordered pair of cows within our tree map, and basically check whether they will collide or not. And from there, we can just do a series of if statements that will check our result. So basically, if result equals 1, that means that the north cow will collide first. So that means that not stop points. Our distances must get updated. So NC is equal to. So in this case, the north stops. So that means we have to record the east cows change against the north cows. And basically from there, that's going to record the distance that the north cow traveled before stopping. And after stopping, we just got to remove it. So remove and keep. And from there, if I is not equal to north size minus 1, and key. So basically, this is just checking. If I is not equal to north size minus 1, we always got to increment. Basically, if we're not on the verge of stopping because we have no more tree maps, or nothing left in the tree map, we still have to increment to the next one. So for tree maps, it's just going to be north dot get higher key and key, and NC is going to be equal to north dot get n key, and this is what we did before. Alright, cool. So let's see here. Next, we have to code for else if result equals to 2. In this case, the east cow stops first. Scroll down a bit. So my mouse just has a really bad scroll wheel. So else if result equals to 2, then well, that means we just record the distance that the east cow traveled. So say dist EC is going to be equal to the cow's NC 0 minus cow's EC 0. Right, so and then we just like I said again, cows that stop get removed. And we don't need to do anything here like we did for the north cow, since this is a nested loop, and the east cow's loop is in a while loop, so we don't have to really care about that. So else, that means that we get 0 and the cows don't collide at all. So that means that one of them is the east cow is going to go infinite. And if I is not equal to north dot size minus 1, we just do the same thing here. Let's just copy and paste. Alright, cool. Let's see what else we have to do down here. Okay, so let's see. Let me do that. Alright, so let's do it down here. What's this? Yep, there we go. And C equals. Alright. So after that, we also have to update the north size, since we are using a for loop. And basically, when the size of the map dynamically changes, we can't iterate through it with in an orderly fashion. It's going to get mixed up. So we also have to do that. And if both of these maps sizes, not here. Can we? Sorry, my typing's so bad right now. Basically, the cable for my microphone is over my keyboard, and basically, if I type, there's like a huge noise to the mic. I think you heard it right there. I don't know, but yeah, equals to 0, and east dot size is equal to 0, and then we break out. So what are we doing here? Well, if both of the maps don't have any cows, that means either they go infinitely or they already stop. So that means we're done. Our job is done. We counted which ones stopped and which ones are going infinite. So from there, we can just print out our answer. And that's going to be done. Let's see. Wait, what's this one? Yep. So after all is said and done, what are we here to do? We're just going to print out the distances. So first of all, if the index is not equal to 0, that means it's a distance. So we print it out. Otherwise, that means it goes to infinity. So we also print out something, but it's not a number. It's infinity. Alright, cool. And I think that's about it. So there you go. I think that's a complete solution for this problem. I'll go over it right now. So basically, we just created 2 tree maps. We check them and store them, and then we use our keys and we update north size every time. Basically, each time checking for which cows will collide, and from those results, we get the distances. And if they don't collide, that means one of them is going to go infinite. So let's go over it again. It's kind of long. If you need to pause the video, go ahead. And there you go. That was Stuck in a Rut in the 2020 December contest. So let's just try running it now. Let's just put in our file real quick. This one. And let's just submit. A really swift grading in progress for the USACO. Great, props to them. And boom. So there it is, Stuck in a Rut. 2020 December contest solved. So thank you guys for watching. Hope this video was helpful in this problem. I know a lot of you kind of maybe struggled on this problem in this year's bronze contest, and I decided to take a look at it, and I thought it was a great problem. So thank you guys for watching. If you enjoyed, please consider subscribing. It's free, and you can always unsubscribe later if you feel like it. So yeah, thank you guys, and I'll see you in the next video.